You guys really do have a great resource right here that I'm showing, learning support services for all kinds of tutoring. And this would be the resource you use if you have, I mean, you can have physics questions, obviously, but really, I think the most immediate benefit would be they can help you with trig, algebra, and calc, all the prerequisite stuff. And on top of that, physics, obviously. So just wanted to remind you guys about that. All right, so now we have another block and pulley. So it's one of these kinds of problems. So we're starting to see, hopefully you're starting to see that there's a certain amount of variety in force analysis, but there's not an infinite amount of variety, which is good. You have to get your arms around the variety that we have here, which is not unreasonable. This is not a crazy heavy workload. All right, so this says, this says in the figure, blocks A and B have, so I know the weight of block A, I know the weight of block B. Fine. Determine the mass of block C that's needed to keep things stationary. Determine the minimum weight of block C to keep A from sliding. That's the question. That is the question for part A. So free body diagram time. Recipe item number 1. And now I have 2 bodies, so I'm going to have 2 free body diagrams. All right, so it looks like this. And you know what I'm going to do? I'm going to combine mass A and mass B. I'm not saying you have to do it. I'm just saying I'm just going to do it now because they're sitting right here. They're moving together. So, okay, I'm just going to call them a single mass. So I'm going to call them a single mass, and I'll just call it mass of AC. Mass AC is the combined mass of block A and block C. Okay, so what are the forces acting on that? Let's do the free body diagram. I have tension pulling to the right. I have the normal force, or the weight force, I should say, is going straight down. I have the normal force, which initiates at the shared contact surface. There's my normal force. Do I have friction? I do have friction. And remember what static friction is telling or is doing. Static friction, F subscript S stands for static friction, opposes velocity tendency. It doesn't oppose velocity. It opposes velocity tendency. So you can see in this situation, what's the velocity tendency for block AC? Well, you can see this is the tendency. This is the velocity tendency. If it was going to move, it would move to the right. Now it's not moving because of static friction, but that's why I'm calling this is the velocity tendency. And the only reason I'm doing that is to make sure I know to draw the static friction force like this. It's the static friction force that's keeping things motionless. All right, so this is static friction force. This is MAC times G, the weight of block AC. Up here, this is my normal force. Got it. This is my tension force acting on AC. I'm done. I'm done with the free body diagram for block A. What about for block AC? What about for this mass right here? I've got tension going up. This is tension acting on B. I've got the weight force pulling block B downward, acting from the center of mass. Okay. This is mass of B times G, and that's it. Those are my only 2 forces acting on block B. And I can say this right here. I can say the tension AC, that tension AC force is in fact the same as the tension acting on B. So let's just call it T. Why is that? Same string. And technically I should say same string massless pulley. Because in a subsequent chapter, we're not going to say the pulley is massless. And if the pulley is not massless, it does change things. So for now, that's a valid statement. Okay, we need to find the minimum weight of block C to keep things motionless. The minimum weight, not the minimum mass, the minimum weight. So I'm going to start with let's start with an X-force inventory. So here goes. The sum of all X dimension forces, and I should say for MAC. Okay. So if I add up all of those X dimension forces, I've got minus Fs, because that's going in the negative X direction, plus T. That tension is going towards the right. I guess that's it. Those are the only two forces equals MA. And here's MA. The mass is MA plus MC times acceleration. And I can see, you know what I have to do right now? I actually have to worry about the coordinate system. So back to my recipe. I have the free body diagram, which is done. I have the coordinate system. And now this is, do I know the direction of acceleration? Yes, for sure I do. I know that it's along the table surface. So for block, need a different color, for block AC, the acceleration is along the table surface. So that's good to know. For block B, I know for sure it's vertically up or vertically down. So if I'm calling this plus X, if I'm calling this plus X for MAC, I have to call this plus Y because I need flow. So I need flow between these coordinate systems. So X needs to keep flowing all the way to Y. So that's the flow I'm talking about. Let me draw that again. This needs to flow all the way through. Darn it, it's hard, easier said than done. This needs to flow all the way through my Y coordinate. So this is what I mean by flow. Flow. That's a flowing. That is flowing. This is flowing. Flow has to be aligned. All right, that's good. That's my free body diagram. That's my coordinate system. I don't have any two-dimensional vectors, so decomposition doesn't need to be done here. There is nothing to decompose. And then it's the inventories. And then the acceleration statement. So here goes. I do have the inventory for block AC. Let's do the inventory now for block B. So I'm going to do a Y force inventory for block B. Very exciting. I have the sum of all Y forces acting on block B. And if I look at block B, I've got negative T because that tension is going upward. And upward is now called negative, plus the weight force, MBG, equals M B times AY. Say something about acceleration, A sub Y. I'll say it like this. A sub Y is the acceleration of block B. The block B acceleration is the same as block AC, which means, I kind of forgot this here. I got to go back here and do 2A. Say something about acceleration, which I neglected to do until now. It's not too late, but this should be X. In here, A sub X, this is referring to the acceleration of block AC. And once I'm just gonna repeat this. The acceleration of block AC is the same as the acceleration of block B. So let's just call them all A. Got it. And I'll do that here. Same acceleration statement. And why is this? It's important to note that this is because my coordinate, where am I? I'm in the wrong chapter. There. Why is that acceleration statement true? It's brought to you by aligned, meaning flowing together, coordinate systems. And same string. There's a string attaching those. Okay. So let's finish this. Step 6. I'm back to step 6. Okay, step 6. Well, here's my Y inventory. I got minus T plus MBG equals MBA. So this is all I can do. I have taken my Y force inventory for block B as far as I can go. And you know what? As I look at block AC, I haven't taken that as far as it can go. I need to go back, and I'm just gonna, I guess, do 2B. I have to return to my X force because I kind of left it incomplete. All right, so if I keep going here, negative F sub S. Negative F sub S is negative mu sub S times F sub N plus T equals mass A plus mass C. So I should have done this before, but I'm doing it now times A. And now 2C is do a Y force inventory. Do a Y force inventory to find F sub N. And you know what F sub N is equal, but we're going to go through the steps anyway, because sometimes it won't be so easy to identify. The sum of all those Y forces acting on MAC. Well, I've got F sub N going up, and I've got weight going down. MA plus MC times G equals A sub Y was MA sub Y mass times A sub Y. And we know that's equal to 0. A sub Y equals 0 since there's no plus or minus Y motion. Block AC just stays on the tabletop. All right, so that's where I'm getting the normal force is in fact the weight of A plus C. Okay, so now that's it. I have, this is my X force inventory for block AC. Fine, there it is. This is the Y force inventory for blocks A and C. And once again, this was the Y force inventory for block B. So from these equations, can you get the weight of C? So here's the thing. Let's get mass of the C. So number, I'm at number 7.
Quick
number
question,
7.
real quick.
Yeah.
Why is FN positive in the Y force inventory? Why wouldn't it be negative?
Right here, you mean?
Yeah, so yeah, why wouldn't that be negative? The one right above it, because the Y is going down. So
This is
wouldn't
for
MA?
this is the X force inventory for AC. There is
Yeah.
no There's no normal force for block B because block B is not in contact with another object. So this is the X force inventory for AC. Let me just trace through this. I've got friction going to the left, tension going to the right. That's it for the two forces. Mass times acceleration. There's my acceleration statement. So then I end up with, and then here's my replacement for static friction. Static friction is defined as F sub S equals mu sub S times F sub N plus T. All right, so I think step 2B looks good. And then Ty, for 2C, I am doing a Y force inventory still for MAC. Not for massive B. So for MAC, I've got the normal force going up. Yes. And I've got the weight going down.
But
okay.
on the flow diagram, the coordinates, you have y plus y going down. Is it?
I have plus Y going down for mass B, but again,
Okay.
step one through 2D is all for mass AC. So does that make sense?
Yeah. So AC has a different plus y going up. Plus y is going up for AC.
Oh, that's a good point. That's a good point. That's a good. So you're right. I have to specify. It's a very good point, really. Let me zoom out. Let me bring things down a tad. Oops, sorry. Okay, you are correct. I specified an X coordinate for AC. I also now need to specify a Y coordinate there. Okay, plus Y. That's a good point you bring up. Okay, so yeah, this Y coordinate here and this X coordinate here, these pertain to MAC. So all of this is the world of mass AC. This coordinate system here, this just pertains to the world of mass B. And what links them together is, once again, the fact that they flow. This axis flows with this axis right here, flow. So that's a very good point. Because you were thinking, I think you were saying, wait a minute, you said the y-axis was downward. I said the y-axis was downward for mass B, but I'm saying the y-axis is upward for mass AC. Although, to be honest, I could have flipped this. If I wanted to, I could have done this and it wouldn't have changed anything. I could have done that and nothing would have changed, but good to know. Good to know you're paying attention to those details. That's definitely a healthy sign. Okay, so does that answer your question, Ty?
Yes, thank you.
Yeah, good question. So now let's combine 2B, 6, and 2B, 2D, and 6 to find MC. I'll stick with this instead of just saying, go knock yourself out with the algebra. Normally, I'm fine saying that, but here, let me just stick with this. I'm just going to line them all up. Here's 2B, negative mu sub S, F sub N. And I'm going to do the substitution right now. So instead of writing down F sub N, here's F sub N. So negative mu sub S times F sub N, there's M A plus MC times G. So good. I have just taken care of this. There's negative mu S Fn. This is negative mu S, and this indeed is Fn right here. Plus T. Let's keep going with number 2B. Plus T equals MA plus MC times A. Okay. Now I'm combining it with number 6. This is what I got from number 6. I've got minus T plus MBG equals MBA. All right. So that's it. I am now going to take these two equations, solve for A. Let's do that. Let's get a numerical value for acceleration, because you can see, for me, the way I do it, you don't have to do it this way, but the way I do it, I'm just going to do equation addition. All right, so this minus T and this plus T will offset each other, which means I'll let you solve for A. So let's all solve for A. Oh,
Wait, how are we supposed to find acceleration if we don't know MC?
oh,
Because
hang on.
I think we're supposed to have A equals to 0.
So
since
yeah,
it's
A
supposed
is
to be
equal to 0. Determine the minimum weight of block C to keep A. So let me update this, and then there's another update here. So let's see, 2B. All right, so let me do some updates here. The acceleration is equal to 0 in this case. C needs to be whatever it needs to be to keep things motionless. So here's some updating. That's fine. All right, so this will be the new 2B. I'll say 2B new. The new 2B is minus coefficient of static friction. So it does get a lot easier, times F sub N plus T equals 0, because nothing's accelerating. And then we can say this. We can say the new 2D new. So this is what we get. We get tension equals mu sub S times F sub N. So let me draw a circle around that. And then over here, this is equal to 0. So, and I should say equals 0. And I should say here equals 0. So number 6, this is what number 6 becomes. I have negative T plus MBG equals 0. So I'll draw a circle around that. This is still good right here. All right, so let me do a little bit of damage control by erasing this. Okay, so I have step 7. Here's my new step 7. Combine number 2D, the new 2D, the old 2D. This is a little bit less than elegant. And 6 new. All right. So I'm going to combine these equations. I'm going to combine this. I'm going to combine this. And I'm going to combine this to get MC somehow. I don't need to solve for acceleration because I know acceleration is there. So you're right, Lewis, you are right. So I have, if I have T equals mu sub S F sub N, and I have minus T plus MBG equals 0. That's right, isn't it? I think so. And then if I have F sub N equals MA plus MC times G. Now I think, unless I'm still making a mistake, which is possible, but now solve for MC. And then once you solve for MC, you're going to do step number 9, convert MC to weight, because they're looking for a weight, which means you're going to take weight equals MC times G. So let's get an answer for the mass of C. Oh, look at the time. And then multiply by 9.8. So let's go ahead and solve for MC. And I think that's kind of doable. Note. What's the mass of B? The mass of B equals the weight of B over G. So for me, the mass of B equals the weight of B, 22 newtons, divided by 9.8 meters per second squared. So this is mass B. Same thing for mass A. Mass A equals weight of object A over G, which means for me, the weight of object A is 47 newtons all over 9.8 meters per second squared. So that is the result for mass A. This is my result for mass A and mass B, which I will need. Oop. This is mass B. This is mass A. Okay. Mass of C for me is 57.8 newtons. That's the answer to part A. What's part B? What's the acceleration of block A? All right, so we're running a little bit overtime here. So what I'll do, I'll keep going here. I think all these quizzes are open till 5. So I'm just going to keep going, knowing that you might have other commitments you need to get to. But for part B, what's the acceleration of block A if there's less friction here? Okay, so that would be, let me be a little more coherent now. Part B, if the static friction, kinetic friction, what is the acceleration of A if mu sub K? Block C is removed. All right, so for part B, we're saying block C is suddenly lifted off if mass of C is removed and the coefficient of kinetic friction equals 0.14. What is the acceleration of block B, block A, I should say? What is the acceleration of block A? That's the $sign. All right, so let me kind of fast track this. All right, so my new X-force inventory for block A, there is no X-force inventory for B, but if I look at block A, and again, I'm fast tracking this a bit, there's no more mass C. So I have minus Fs plus T equals mass of block A times A. That's not equal to 0. A is not equal to 0. So the acceleration of block A is going to be the same as the acceleration of block B. So let's just call it A. So here's my X-force inventory. I have minus Fs plus T equals, I didn't say anything different here. So here's my X-force inventory. Having said all this, minus mu sub K times F sub N plus T equals mass of A times A. A is not equal to acceleration. I know the normal force. So again, in the interest of compressing time, I know the normal force. I think you know the normal force is just going to be the mass of A times G. So I'm sidestepping the Y force inventory because I think you can maybe kind of see that, yeah, this is the normal force. Okay, plus T equals MA. So that's it. That's my X force inventory, which also kind of included the Y force inventory. I'm going to highlight that in yellow. Done with the inventories for block A. Here's the inventories for block B. The Y force inventory for block B. Is as follows. I have the sum of all those Y forces is minus T plus MBG equals MBA. Just again, because I have the acceleration of block A is the same as the acceleration of block B. Let's just call it A. And that's it. All right, so I have these two equations now. This is the result of my inventory for block B. This, once again, is my inventory for block A. Let's solve for A. Yes, we can do that. Okay. 19. Solve for A. Solve for A from number 15 and number 17. Okay. And I get A equals 2.19 meters per second squared. So at this point, kind of went over 10, which I try not to do. This is the answer to part B.